All right, so let's take a look here at the antiderivative of 1 over x. Now, just as a quick side note here, you know, for anything else, if we were doing like the integral, for instance, of like 1 over like x squared, well, what we would do is we'd rewrite that as the integral of x to the negative 2 dx, and we would just apply the power rule to that. What we do is we'd add 1 to the exponent to make it negative 1 and divide by that exponent of negative 1. So it would be negative 1 over x in that case. Same thing as negative x to the negative 1 plus c. And that would be the same thing if this was 1 over x cubed, 1 over x to the 5th, 1 over x to the 2.3. It would be, you know, all the same. But when it's 1 over x, that doesn't work because this exponent, when it's 1 over x, okay, let me go and erase this real quick, becomes 1. So if I tried to apply the power rule to that, right, I'd have the integral of x to the negative 1, and think of what would happen. If I added 1 to the exponent, I would get 0, and then I'd try and divide by that. We all know it's super evil to divide by 0, so it doesn't work, okay? But there still is area under the curve of 1 over x, and so it ends up being that the antiderivative of 1 over x is equal to natural log absolute value of x plus c, okay? So this is one we got to keep in the memory banks. We got to remember that. Okay. Now, but this can be applied more broadly than just this one antiderivative. So basically, it comes down to the pattern that I'm going to point out here is that notice the derivative of x is equal to 1. So if we ever have something where the derivative of the bottom is equal to the top, then we can apply this natural log rule. It's just natural log absolute value of the bottom. So for instance, if we have like 1 over 2x, let's say for instance, 1 over 2x, okay? Well, if I look here, the bottom right here is 2x, so the derivative of that is 2. Well, bummer, the top is 1, okay? So it's not in the form that we want. Again, we're looking for it so that if the derivative of the bottom is equal to the top, we're in the same form up here, because the derivative of x is equal to 1 there. But we can manipulate here, because we're just off by a constant. You can never manipulate if you're off by x's or anything like that, but we're off by a constant, 2. So what I'm going to do is I'm going to multiply by 2 over 2 on the outside. The reason I chose 2 over 2 is because 2 over 2 is equal to 1. So what I'm doing is I'm multiplying by 1. So I'm not changing the value at all. Okay? And what I'm going to do now, constants you can bring inside or outside the integral. X's or variables you cannot. But constants you can. I'm going to take this 2, I'm going to bring it inside the integral. So when I do that, on the outside I'll be left with a 1/2. On the inside, when I bring the 2 in, I'll have a 2 on top over 2x dx. Okay? And now I have it set up perfectly such that the derivative of the bottom is equal to the top. The derivative of 2x is 2. So now I can apply this natural log rule for antiderivatives. So, what have we got going? The 1/2 is a constant. It's going to go along for the ride. But since this is set up perfectly to use this form, the rule says then it just becomes natural log absolute value of the bottom plus c. So that's the antiderivative of 1 over 2x. Okay? I guess I also could have, if I wanted to, just brought this 2 out from the beginning to make it a 1/2 initially. And it would have been 1/2 natural log absolute value x, which is actually the same thing. I know it seems strange, but it actually is the same thing as 1/2 natural log 2x, because you can just absorb the natural log 2 in the constant. But let's look at another example that might be a little better even than that, is something like this. How about, so say something like this. So I notice that the derivative of the bottom is equal to 3x squared. So the top is only off by a constant, only off by 3. That's it. So again, it's not off by x's at all, it's only off by a constant. So what I want the top to be 3x squared so I can apply this rule. So I'm going to multiply by 3 over 3 on the outside, because again, that's just multiplying by 1. And I'm going to bring this inside to make it so on the outside I'll be left with the 1/3 integral of 3x squared over x cubed plus 7 dx. Now I haven't changed the value at all, it just looks a little different. But it's set up so that if I take the derivative of the bottom, which is 3x squared, that's on top. So again, the derivative of the bottom is equal to the top. That has to be set up like that to apply this rule. So the 1/3 is a constant. It would just go along for the ride. The antiderivative of this would just be natural log, absolute value, x cubed plus 7 plus c. Don't forget that absolute value. You got to have that in there. If you forget that, that's not going to be looked upon too highly right there. Okay?